Currently, we have three North American operators deploying LTE. Typically, we think of that in the 100 megabit per second to the 300 megabit per second capability. Those deployments are based on today are based on Release 8 of the 3GPP standard. The ITU has accepted LTE Advanced as a formal 4G technology. We'd expect those standards to be ratified, the Release 10 to be ratified about a year from now, and then probably another 3 to 5 years beyond that would be a typical cycle to see deployments begin.
If you look at the broadband network that AT&T's deployed on wireline, it's very process-oriented, very standardized engineering set to expectations. Mr. Stevenson highlighted, and to your point, as this network gets more complicated, has more demands, they need to take that standardization mindset from its wireline world and move it to its wireless world. We've seen instances, particularly on passive connectivity, when you look at the variables from the top of the tower to connecting into the active network, in the variations of millions, tens of millions of options. So it's difficult to design for speed, design for efficiency, and guarantee performance with all those pieces that come together.
As far as integrating Wi-Fi into the cellular network, right now, where we are with the deployments, we don't normally recommend that because for the reason the footprints are distinctly different, the coverage footprints, the coverage requirements are. We have some longer range solutions that we're working on right now that drive the cost down to of the remote radio, what we call the remote unit, to where the footprints start to become very small. You know, that's where, and I think the integration of Wi-Fi and cellular makes sense, where you're plopping these remote access heads every 25 to 50 feet spacings. Then the footprint starts to become somewhat irrelevant. But there's cost deltas that have to hit before the cellular network gets to that thing. So you're talking about trying to have coverage footprints that are matched at basically if you're looking at a multi-operator system, 8 different frequency bands.
We have seen one global carrier very creative in this environment where they use an energy savings contract. CommScope's cooperated with this individual where in essence you measure the power consumption of a site, say a shelter, before integration of a new energy saving solution, which would include shelter cooling and fuel cell, and then measure afterwards. And the distinction to that, the savings between the before and after, in essence, a third party would come in and install these products at no capex to the carrier. And in essence, the carrier would pay the same net OPEX. They would pay the power difference, and after a period of time, they would own those assets. This is called an energy savings contract.
So the antenna for a wireless system is like the speaker on a high fidelity audio system. You have a lot of fancy electronics behind it, but unless that speaker is high performance, then it degrades the whole point of having the high performance electronics. So the antenna really is the last thing that the signal encounters before it goes over the air. So we see a lot of attention. Matt mentioned the 3G and the 4G technologies have higher orders of modulation, we call, which again, that means that containing the interference is more and more important. And pattern control, we call it, is more and more important to contain those signals so that they don't interfere with the neighboring site. So we do see measures being taken to roll out higher performance antennas to, again, help maximize the throughput of the new technologies, the new data technology. We do see, from the perspective of containing OPEX, we do see a continued trend. This really started from the transition to 2G and to 3G, but we see what we call multi-band, multi-service antennas. Some call them broadband antennas as well, where more than one wireless service or technology can be transmitted and received by the same antenna.